So we've got 11.1, simplifying radical expressions. Today, you should be able to say that I can simplify radical expressions using the product property of square root. So we're really focusing on maybe just blow this up just a little bit. The thing that we're really focusing on today is the top thing, simplifying radical expressions using the product property of square roots. Tonight, when you watch your video, it's going to be simplifying radical expressions using the quotient property of square roots. So today it's product property. What's product? What's product? I want to activate someone else's brain. What's a product? Yeah. Yes, answer to a multiplication problem, and quotient is, and my son's dealing with this in 4th grade. He's expected to know this. Answer to a division. Good. There's nothing wrong with being wrong, right? Anyway, this is directly from your book, The Product Property of Square Roots. A radical expression is an expression that contains a square root. Okay? So it's the expression that contains that. A radicand, the expression under the radical sign, is in simplest form if it contains no perfect square factors other than 1. So for example, 24 is not, the square root of 24 is not simplified because 6 times 4 is a product of 24, and 4 is a perfect square. It's not simplified. We're going to learn how to simplify those today. The following property can be used to simplify square roots. So the product property of square roots shows us that square root of a times b equals the same thing as the square root of a times the square root of b. For example, the square root of 4 times 25 can also be the square root of 4 times the square root of 5. What's the square root of 4? 2. What's the square root of 25? Yell it out. 5. So 2 times 5 is 10. So the square root of 4 times 25 is 10. Well, think about what 4 times 25 is. What's 4 times 25? 100. And the square root of 100 is 10. So we're going to use that idea we're going to break apart like a number in order to simplify it. The product of square roots and prime factorization can be used to simplify radical expressions in which the radicand is not a perfect square. Okay? So we dealt with prime factorization in 5th grade and 6th grade, and now we're really gonna hit that home today in order to simplify these. So I've got the square root of 52. Okay? So we have to ask ourselves, is this simplified? And in order to tell if this is simplified, what we're going to do is we're going to first pick up our, we're going to take just 52 all by itself, and we're going to take the prime factorization of 52. And we know it's not a prime number. Why do we know that 52 is not a prime number? It's an even number. Good. What are 2 numbers that go into 52? Yes, sir.
2 and 26.
26. Good. 2 and 26. So it's simply cut 52 in half, and you got 2 and 26. So we know that. And do you remember doing these in 5th grade? What are these called over here? Factor trees. This is prime factorization. You use factor trees in order to find this out. So do we have any more factors for 2 other than 2 in itself, or 2 and 1? No? No? Okay, so that's a prime number. I always like to circle them. I don't know what you like to do, but I'm not going to go over factor trees all the way, but I like to say that tells me to stop. I don't need to factor that one anymore. Cool.
26 is 213.
Okay, 2 and, is it 13?
Yeah.
Cool. So radical 52 can be written, the same thing, it can be written as 2 times 2 times 13. I mean, if you wanted to, you could write this as, you can even combine 2 and 2. I don't know if you want to. Maybe I would do, you could also think of 2 and 2. We're really looking for pairs of numbers, not triplets, pairs. If we have pairs, we can pull it out because that's a perfect square. 2 times 2. 2 times 2 is the square, or the square root of 4 is a perfect square. So I've got the square root of 4 times the square root of 13. You don't necessarily have to write it out like this, or if you see your pair, you can write it all together. But what's the square root of 4? 2. Or you just pull this 2 out of here, and you're left with the square root of 13. 13 is a prime number. They don't always have to be prime numbers under here, but we know that they don't have any other factors. So there's a prime number is always going to be simplified underneath the square root sign. So the square root of 52 is simplified to 2 times the square root of 13. So in your calculator, if you have a calculator at your desk, put in the square root of 52. We got a few of you who have those at your desk. Let's put that in. Put in the square root of 52. And press enter. And then do 2 times the square root of 13. Then do 2 times the square root of 13.
6.5.
Are they the same thing?
Yeah.
And what's the approximation of these? Somewhere a little bit greater than 7, but less than 8?
Yeah, it's like 7.21. Then there's like a bunch of 1, 2, 0, 2, 5, 5, 1.
Good. How do I know that that's in between? How do I know that's in between 7 and 8? Probably a little closer to 7. Yes, sir.
52 is in between 49 and 50.
What? I couldn't hear you. I'm sorry. Good, Lucas. Yeah, it's in between 49 and 64. The square root of 49 is 7. Square root of 64 is 8. I know it's somewhere in between 7 and 8. It's probably a little closer. 52 is a little closer to 49 than it is 64. So it's 7 point, what is it, 7.2, 7.1?
7.2111022. I mean 255.1.
And it goes on forever and ever. And that's in your, the square root of 52, then, the square root of 52 is an irrational number. So that's the number that goes on forever and never goes. So not irradical, but irrational. Okay? Next number. Next number. I want you to do the prime factorization of 72 at your desk. Go ahead and do that. I'm going to press pause. All right. So square root of 72. Someone give me 2 factors of. Give me 2 factors for our factor tree. What do you got? What do you got? Yes, sir.
2 and 36.
2 and 36. We're going to talk about this in just a second. This step right here. Okay. Is 2 prime? Certainly. Now where can I go?
36. 2 factors.
You can go to 36 and find 2 factors of that. What are 2 factors of that? Yeah. 6 and 6. You actually have a pair right there. You don't have to go any farther. Okay, you could actually stop right at 36 because that's a perfect square. We're going to talk about that in a second. 6 is not prime, so we have to keep on going if we're doing prime factorization. Jasmine, 2 and 3. Both of them are 2 and 3. And we know that 2 and 3 are prime factors.
And 2.
Okay, so now I've got the square root of 72 can be written as 2 times 2 times 3 times 3 times, actually I should put 2 times 2 times 3 times 3. I like to keep all the numbers together. Then notice right here I've got 2 times 2 and I've got 3 times 3. I might think of that as the square root of 4, the square root of 2, and the square root of 9. Okay? What's the square root of 4 equal? 2 times, what's the square root of 9 equal?
3.
3 times, what's the square root of 2? That's 6. It's not a pair. Square root of 2 is the square root of 2. Okay? So notice, I pulled this 2 out, and I pulled this 3 out. So I pulled this 2 out, and I pulled this 3 out. Well, 2 times 3 is 6 radical 2. Notice way back up here, when we did 2 times 36. I would have done 9 times 8, but I was glad that we chose 2 times 36. 36 is a perfect square. Square root of 36 is 6. 9 times 4 is 36. That's where that comes from. 6, and then we're left with the square root of 2. Yes, sir.
So here's where I have my question. Okay, so you got down to where you have that where you have the what should we call it sign on
Square root.
4, 2, and 9, those numbers.
Yeah.
So the outside numbers there's like and now the entire thing it would multiply to 72.
The entire thing, any of these, if I take these, those multiply to 72. 9 times 4 is 36. 36 times 2 is 72. 2 times 2 is 4. Times 2 is 8. 8 times, and then I got 3 times 3 is 9. 8 times 9 is 72. Any of these equals the square root of 72. And then if I put in my calculator the square root of 72, I can do 6 times the square root of 2, and that equals the same thing as the square root of 72, which I know is in between what 2 whole numbers? Daniel? 8 and 9, right? The square root of 64 is 8, and the square root of 81 is 9. 9 times 9 is 81. 8 times 8 is 64. So it's somewhere in between there. It's almost like right in the middle, which it's probably closer. What's it closer to? It's closer to square root of 9. Isn't it? 8. Yeah, sorry. Yeah, but it's pretty close. It's probably about 8.5. So, anyone got? Jaden, check it real quick. Is it about 8.5?
Yeah.
Cool.
It's 8.48.
8.48. So yeah, it's real close to the middle, but it's closer to 8. Anyway, so another way you can do these is you can write out all the factors for a number. So if I took 72, and some people might want to do this approach. If you write out all the factors, you don't have to do 1 times 72 unless you know it's prime, but you start with 2, and we know it's 2 times 36. How many times does 3 go into it? How many times does 3 go into it? I know it does. Yes, sir. 24. 4. Does 4 go into 72? How many times does 4 go into it, Cole?
4 would go into 72 exactly 18 times.
Okay. 5 go into it? Connor, leave. Leave. When you come back in, if you come back in and you talk, I'm writing it up as a minor.
Okay.
Does 5 go into it?
No.
And you come back in on your own time.
Alright.
You're ready. Does 6 go into it?
Yeah.
How many times does 6 go into it?
Well,
7? 8?
yeah.
How many times?
9.
And that's our turnaround time. Okay? So then what you do is you look for perfect squares. Is 2 a perfect square? Is 36 a perfect square? Is 3? 24? 4? 18? 6? 12? 8? 9? And then you pick out your largest perfect square. Your largest perfect square is square root of 36. Square root of 36 you can pull out of the equation. So, or if there were 2 others, we know 9 times 4. But really, your best way of doing this is doing prime factorization and looking for pairs. I find that's the best way. You won't miss anything using prime factorization. Okay, next. Square root of 2 times the square root of 24. We can think of this in 2 different ways, even though we have 2 different numbers. But we know, if you know the square root of 2 is already simplified, just leave it like that. But you can also, if you want to, you can do, that's the square root of 48. I don't know which is better, but I know that this is like that. I know that's simplified. I know the square root of 2 is simplified, so I'm going to just deal with 24 in this case. So in this case, I'm just going to erase this, but I'm going to deal with just the square root of 24. And let's find out, let's simplify this and see if the square root of 24 has any perfect squares in it. 2 factors for 24. We've already done this problem, but what are 2 factors of 24? Yes, sir. 2 and 12. Okay. 2 simplified at 2 factors for 12. Brendan. 2 and 6. Already, notice we've got 2 pairs. 2 factors for 6, Jasmine. 2 and 3. So now what we have is the square root of 2 times 2 times 2 times 2 times 3. So I write all of these, including this first one, underneath the square root.
Wait, how's that?
Because of this one here. Because remember, when we're multiplying together, we can put them all underneath, going back to this. Going back to this right here, the square root of AB is the same thing as the square root of A times the square root of B. So it works either way. So if I come back to here, even though it's the square root of 2 times the square root of 24, I'm going to put them all underneath here and then look for pairs. That way I don't have to do 48. 48, I already know it's 24 times 2 is 48. And it would just be, the first one would be 2 times 24, right? So anyway, so then I look for pairs. Here I've got a pair. Here I've got a pair. So I can pull, that's 4, that's 4. The square root of 4 is 2. The square root of 4 is 2. So I got 2 times 2, and what's left under the radical is 3. And if you wanted to, I would have multiplied those together to begin with, but 2 times 2 is 4, the square root of 3. Okay? Easy enough? Make sense? And if you wanted to, again, you could have gone to this and done the square root of 48 and said, well, that's 2 times 24, and then that's 8 times 3, and that's 4 times 2, and that's 2 times 2. And I've got 2, 2, 2, 3, and 2. Same thing that I have underneath here. So if you wanted to combine them at the beginning, that's fine by me too. I don't care what's easy, whatever's easiest for you. You can always check your answer with your calculator. Does 4 times the square root of 3 equal the same thing as the square root of 2 times the square root of 24? Do they equal the same thing? They should. Move it on. Oh, variables. So variables, same thing here. we can deal with variables. Okay, we're going to write this whole thing out. But first, what I want you to do is the prime factorization of 45. Do that. Let's give you 30 seconds. Go. Okay, tell me the prime factorization for 45. Prime factorization for 45. What do we got? Yes, sir.
9 and 5, and then
9 times 5. Good.
3 and 3.
3 and 3. We know that. We know 9 is a perfect square, but we can show it this way. So here's what we do on this. We also write this out, the prime factorization of A. Well, A is the same thing as A times A times A times A. And I'm not going to do this for all of them, but I'm going to show you how it works here. And you won't have to always write it out like this. You'll start to figure out what you have to write out, what you don't. But here you've got 3 times 3 times 5 times A times A times A times A times B times B times B times B times B times C times C times C times C times C times C.
Or C. No, not
No. And then I look for pairs.
Oh my gosh.
Pairs. Pairs. Pairs.
Try to all the pairs. You're making the problem easier.
Pair.
Okay? So I can pull those pairs out. Okay? 3 times 3 is 9, or the square root of 9 is 3. Oops. Okay? So whatever the pair is, I can pull out from underneath there. A times A is A squared. Well, the square root of A squared is just A. Just like if A was 3, 3 times 3 is 9, the square root of 9 is 3. So we've got A, we've got another A, we've got another B we can pull out of the square root, another B we can pull out of the square root, another C we can pull out of the square root, another C, and finally one last C. And then underneath the square root is everything that we didn't pair up. That's 5 times B. So I guess I'll keep this whole thing here. Okay? So now I just combine these. Okay? 3, and then this is A squared, B squared, C cubed. So 3A squared, B squared, C cubed times 5B to the first power. Okay? So notice this. What you can really do here, and instead of having to write these all the way out, is you cut this number in half. Okay? Cut this number in half, or take any odd number, subtract 1 off of it, and cut it in half. So B is the same thing as B to the 4th times B to the 1st. And then take the half of that is B to the 2nd. Yes?
So on test, do we show that first step?
This whole thing?
Yeah.
No, once you figure, I actually want you to get to the point to where you understand
Okay.
B to the 5th is, what I want you to understand is B to the 5th, the square root of B to the 5th is that it's the same thing as B to the 4th times B to the 1st. And you've got B times B times B times B, which is B to the 2nd times B. That's what I want you to get to. Okay? So if you think about B to the 5th, if we just think about that for just a second, B to the 5th, and we give that a number, let's say it's 7. And we know that's the same thing as 7 times 7 times 7 times 7 times 7. If we just substitute it in there, then we know that we've got this pair, which is 49, and this is 49. So it's 7 times 7. So it's 49 square root of 7. Okay? Or b to the second times b to the first. Because that b to the second power is right there. That's b to the first. So the only hard thing is you can cut these numbers just in half and pull it out. You could just say the even ones are easy. A to the fourth is the square root of a to the fourth is just a to the second. The odd ones you just have to do minus 1, and then you have the even number that you can cut in half. So I know that's a little confusing, but you'll start to figure out, right? If you're confused right now, write them all the way out, and soon you'll figure out what I'm saying, because you'll get bored of doing this, writing out all those variables. It'll start to drive you nuts. So that's my suggestion to you. If I just confused you by that whole thing, write them all the way out, and you're going to figure out the shortcut on your own. That's how when I came back to teach algebra and I started, what is this talking about? Why do I have to write all these out? And then I started like, oh, I could just cut that in half, and then add 1 to, or cut that one in half, but add 1 to it. Anyway. All right. So that is what I have for you today. Your homework, I want to go over a couple things for you, what you have to do. And you literally have a half hour. But your homework is write up oh yeah, it's after that one. Your homework and book are already posted. You come up here to chapter. You come up here. You've got 4 through 8, and then 15 through 25 odd. I have marked on here a bunch of other videos, so if you're not understanding what I'm saying, or you can certainly click on that and it'll help you to learn some more stuff that Khan teaches you. You can also work through the exercises that he has for you. And then your next homework assignment is to watch the video. And I'll write it in there right now. I mean, there's no reason why I can't. I'll even post the link. I'll post the link right in there for 11.2. So you need to make sure that you watch the video tonight, or if you get your homework done soon enough, you can start to watch it today. Work through each example. When I say pause or do this problem, do the problem just like you would in class. If you have any questions, write those questions down tonight, or today if you're watching it now. That concludes our lesson. Go ahead and get to work, and you can ask me anything that you may on your homework.